Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. In this video, we will see shear of closed section beam that's related to numerical of that one. Right, so just see here, that numerical part 2 we will see. Okay, so now here is the question. In the panel shown in figure 1, so this is here, the area AS, this is given area here. So this one as AS of the central stringer, right? So central stringer area is given as AS, is to be designed so that the stress in it is 80% of the constant stress. So whatever the stress is applied, 80% stress will applied on this one. So just here, this 80% SE, that is stress SE. So 80% of SE will be applied over here in the edge member, each of area B. So area, this is B, this is, these two are edge member having area B. Assuming that the sheet which is of constant thickness T, so this sheet having constant thickness T carries only shear stress and that transverse strain are prevented. So only shear stress is having and the transverse stress is prevented, means it's not allowed any transverse strain. Now derive expression for AS and B, means what is this AS and B? Okay, in terms of applied load and the appropriate elastic moduli E for the longitudinal member of G for the sheet. Means here till that we have to just find that AS and B, means derive AS and B. Once derive AS and B, right, then just after that only the second part of the numerical that is given as numerical. So first derivation and then second is numerical. So just here, evaluate these expression in the case where P is equals to, it's a given 4,50,000 Newton. Okay, PS is 1,45,000 Newton, S is 350 Newton per mm, SE is given as 275 Newton per mm square, L is equals to 1250 mm, right, B is equals to 250 mm and T equals to 2.5 mm, and already it's a given and that is constant thickness, and G is equals to 0.38E. Means first you derive those two equations and then put this value and then find the value of AS and B. Find the fraction of total tension at the abutment carried by the stringer. So these, whatever these things are there. So what is the fraction? How much load is acting divided by the total load. So that fraction you have to find. So total 3 things you have to find. First, what you have to do? You have to derive the formula for AS and B. After finding AS and B, whatever the given data are there, that you have to substitute and you have to find the value of AS and B. And then next, you have to find the what? Fraction of total tension. Okay, so let's start the numerical. Okay, initially direction for shear flow Q are chosen as shown in figure, so that we can choose any direction. So that's why here initially this direction we have chosen. That is not necessary that you have to choose any direction you can take. If you will take the opposite direction, then your value will be negative. That is the difference. Remaining everything will be same. The panel is symmetrical about its horizontal center line, so that only half need to be considered. So just here, just along this half, so half part only will be there. It's a symmetrical about this part, right? So now just see, it's a given, right? So see the figure here, they just given this direction, that S, right? In this direction, these two. Now here we are considering the shear direction. So just here, that's shear distribution. So this is in this direction. So just here, this and this should be equal and opposite. Similarly, if you are taking this upward, then in this side it should be downward. Now this will affect only this also. So this and this should be in the same direction. So the opposite will be in this direction. So here it's going up. So in this case it's a down. Here it's a going down. Here it's going up. Right? Now just take any cross section at a distance Z. Find for Z and then take from 0 to L. That is because total length is given as L. Now from here to this center, it's a given distance B. From here to here also, it's a B. On the top one, acting P, and on bottom stringer, it's acting that load as P, and here at the central one, it's as PS. So this is the question. Now we have to derive for this one. So in this case, we will do separately. First, we will find for this upper one, then for middle one, and bottom one will be same like just upper one. So right. So let's start with this one. Okay. So now let's see. For equilibrium of element of the top boom shown in figure. So now what we are doing, we are finding for this one. Okay. So just see here. This is the beam. Just we are drawing the free body diagram. So just the right. PB is given, that is acting here, and shear load direction also is given, and you can see the Q direction is in this direction. So just see here. You have to take not this direction, right? Because of this direction will be there. Okay. So now Q direction is this one, and this total distance is how much? That's just assumed as delta Z. That delta Z vary from 0 to L, that we will see later. So if PB is acting here, then this side it will act how much? PB plus del PB by del Z into del Z. Okay. So now what we have to do? So just for equilibrium, this should be equals to this one. The total force should be equals to 0. Right. So now here it's acting PB plus, just see here, this one. Right. This taking this side as positive and this side negative. So after this, what happened? PB. So first this PB plus delta PB by delta Z into del Z. So this positive, then minus PB, because this side we are taking negative. So PB. Right. And this side also acting S for how much distance? For delta Z. So minus S into delta Z. And this Q is acting this side, and this side we are taking positive. So Q into delta Z. So plus Q into delta Z equals to 0. Right. Now let's simplify. So here we can say PB get cancel. Now what is left? Delta PB by delta Z into delta Z. Okay. Minus S into delta Z plus Q into delta Z equals to 0. Okay. Now take these two this side. So what we will get? Delta PB by delta Z into delta Z is equals to, this side is negative, so that side it becomes positive. S into delta Z, and this becomes negative. So Q into delta Z. Right. Now here we can take delta Z common. So delta PB by delta Z into delta Z is equals to delta Z common S minus Q. So this delta Z get cancelled. So delta PB by delta Z is equals to S minus Q. So let's see here, delta PB by delta Z equals to S minus Q. That is equation first. So for top boom, we found that how much delta PB by delta Z will be there. Okay. Now, also for equilibrium of the element of the central stringer. So now top or bottom, any you can find, that will be same. Now for the central one, so central stringer. So now PA will act in this direction. So again that PA plus del P A by del Z into dz will act in this direction. So now just see here in the central stringer. This is central stringer. We have taken this in this direction. So for central stringer, this will be the direction of Q, and this is given here. So just see here. So this is the direction of Q. This is right PA, this one. So here what, that load is not, S is not acting in this one. So just it's not given here in figure also. Right. Here that S is there, but in this stringer S is not there. So here that S into del Z term will be missing. Right. So now same again apply this as positive. So this direction. So PA plus del PA by del Z into del Z. Right. Then minus PA. Right. Minus PA. Okay. So this direction is negative. So minus Q is acting and Q. So minus Q for first, this one Q into del Z. Right. Then for this also minus Q into del Z, that is equals to 0. So PA cancel. Right. What we will get? Del PA by del Z into del Z minus 2Q del Z equals to 0. Take this to this side. So del PA by del Z into del Z equals to 2Q del z. So del z cancel. So del PA by del z equals to 2q. Right. So see, del PA by del z equals to 2q we got. Right. So now we have the what? Along the top and central one. Similarly, it's the 4. Bottom one also will be the same as the top one. Okay. So now just see. For equilibrium of length z, the panel shown in figure. So now from here to here, this is small z that considering, and for this, whatever the panel will be. So just see after this figure. So PB acting in this direction. So this direction we are taking positive. So this direction total force is what? 2PB plus PA. This is acting in this direction. Right. In this direction, what is acting? So that will be minus. So minus P and P. So minus 2P and minus PS. This is there. Right. And now this S is acting in this direction. Right. So S and S. So 2S. So for this S into Z, or let me write here. So this is for this these two 2PB plus PA. This side okay. Now minus 2P minus PS. This force okay. Now this one. So S into plus. So this taking minus. So minus S, and for this one. So minus S into Z minus S into Z equals to 0. Or simply we can write that 2PB plus PA minus 2PS. Okay. Then minus 2P. Okay. Minus 2SZ equals to 0. Okay. Now from here we have to find PA. Right. So just PA. Put PA equals to what? Take everything that side. So this will be 2P plus 2PS plus 2SZ minus 2PB. So just see this PA we got. Yeah. PA equals to 2P plus PS plus 2SZ minus 2PB. That now we got that PA value. Okay. So now next what we have to do? Just see. The compatibility of displacement condition for the top boom and central stringer is shown. How the top boom and central stringer will be there, that compatibility. Okay. So for the top boom, this is 1 plus epsilon B into del Z. And for here, this is for the central one, that is 1 plus epsilon into del Z. So this side it is gamma. Just it's a gamma is a strain here. So this side it will be what? Gamma plus del gamma into del Z. Just now, just apply what? Same for the equilibrium. This will be, this will be equals to this total one. So just see 1 plus EA into del Z equals to 1 plus EB into del Z plus B into whatever this d gamma by dz is there. So d gamma by dz into del Z. So from here what we will do? We will find d gamma by dz. So just see what? First expand this one. So I'm expanding. So after multiplying this, del Z plus epsilon A into del Z, that is equals to what? After multiplying del Z plus epsilon B into del Z plus B into d gamma by dz into del Z. Keep this side and take these two to this side. So del Z plus epsilon A del Z minus del Z, this plus become minus, so this also minus, minus epsilon B del Z, okay, is equals to B into d gamma by dz into del Z. So now just see del Z gets cancelled. Right, here we can take del Z common. So del Z common, what we will get? EA minus EB, that is equals to B into d gamma by dz into del Z. Right. So now this del Z get cancelled. Okay. Now what we have? Okay. So epsilon A minus epsilon B is equals to B into d gamma by dz. So now we have to find d gamma by dz. So just take these to B side, this side. So now this will be what? epsilon A minus epsilon B by B is equals to d gamma by dz. So let's see here. D gamma by dz as epsilon A minus epsilon B by B. So this we got as d gamma by dz. Okay. So now what is epsilon A? Just we have to replace in terms of stress. So strain is stress by Young's modulus. So epsilon A is sigma A by E. Similarly, epsilon B is sigma B by E. That is equals to sigma E by E as constant. Right. Also that is given what? Sigma A is 0.8 E, 80% of E is given. That sigma A. So let's put the value. So right. So just see here. 1 by epsilon A, epsilon B. So just next step will be what? D. Okay. Just let me write here. Okay. What we have? D gamma by dz is what? 1 by B into epsilon A minus epsilon B. That is right. Let's see, epsilon A minus epsilon B. What is epsilon A? So d gamma by dz is 1 by B into what? Sigma A by E minus sigma B by E. Right. So E taking common. So 1 by B E. What we have? Sigma A minus sigma B. This is d gamma by dz. Right. Now sigma is how much? 0.80. So just put that value. So d gamma by dz equals to 1 by B E 0.8 sigma E. And what is sigma B? Sigma B is what? Sigma E. Right. So minus sigma E. So after subtracting, what you will get? Minus 0.2. So dV by, or sorry, d gamma by dz is equals to minus 0.2 sigma E by B E. So here we got this one. D gamma by dz equals to minus 0.2 sigma E by B E. Now in this, right? So this is the equation number 5. Okay. So now equation 5, put gamma equals to Q by GT. So gamma equals to, if you will put here Q by GT, so let's put here. So D into Q by GT by dz is equals to 0. Minus 0.2 sigma E by B E. GT is constant, so that we can out and simply here. So this will becomes dq by dz into 1 by gt is equals to minus 0.2 sigma E by B. Now this gt can come this side. So dq by dz equals to minus 0.2 sigma E into gt by B E. So here dq by dz equals to 0.2 sigma E into gt by B. So now we have dq by dz. Now substituting for q in equation 6, right? For q from 1, right? What we gives that again you have to just differentiate. So delta that dq in terms of pv. So delta square pv by del z square is equals to what? Sorry, 0.2 gt by v into sigma v. So now this is our delta 2 pv by del z square. Now what we have to do? We have to integrate here this one to find pb. So just see here 2 times differentiation is there. Delta 2 pv means we have to integrate 2 times. Right. So let's integrate this one. So first here I'm just taking this one. So delta 2 pb by del z square is equals to 0.2 gt by be, okay, into sigma e. Integrate both sides. Right. So this is just constant. So after integrating, what we will get here? Thus one power will get reduced and we will get del pb by del z equals to what? This one. So 0.2 gt by be into sigma is there and difference integration of one is z. So sigma e into z plus another constant c, that integration constant c they have taken. So just same. Anything you can take, a and b also. So now from here, next time if you will integrate, so here this will be what? Just integrate again. So after integrating, I'll just put here. So this also you have to integrate. So after integrating, we will get here PB equals to, so let's see again 0.2 GT by BE, sigma is constant. Here this time Z integration. So 0.2 GT by BE into sigma, that is constant. Now integral of Z. Integral of Z is what? Into Z square by 2. Plus, now integral of C is what? Cx. And another integral constant, that is as D. So this will be the P integral. So PV equals to what? 0.1 GT sigma E by BE into Z square plus CZ plus T. Now here we have to find C and D. After finding C and D, substitute here, then we will get the value of PB. So how we will find the C and D? Again the same boundary condition. So let's do that one. So see, when Z equals to 0, PB is equals to P. So let's just put here, when Z equals to 0, right? So P and PB equals to P. Okay. So now what is that? When Z equals to 0, PB equals to P. So putting this value here. So PB becomes P is equals to Z is 0. So this whole term will be 0. Right? So 0 plus C into 0 plus D. Right? So from here we will get D equals to P. Okay? So D equals to P. Now when Z is L, then Q is 0. So that del P by del Z equals to S and Z equals to L. So here just put Z equals to L. So this becomes Z square. C already we got. Right? Z equals to L. So after that, what we will get? C equals to what? 0. Because del P by del Z is S. So 0 minus 0.2 GT by sigma E by BT into L plus S. This is C. Now put the value of B and C. So what that in here? So this plus C is what? That D is P and C is this one. So after substituting this, what we will get here? So this is the value of D. This is the value of, this is the value of what? C. So PB equals to 0.1 GT sigma E by BE into Z square plus this S minus 0.2 GT sigma E into L by BE into Z plus P. So this is our final equation for PB. Now another one is there. Now PB is equals to what? Sigma E into B, because we have to find B. So this is the final equation for PB. Now replace PB as sigma E into B. So this sigma E into B. So now this sigma E cancel. Here sigma E term is there. With this it's not there. So after just here, that's why that sigma E directly they have taken constant. That common 1 by sigma E. So whatever the term having sigma E, that will be there. If it's not, then 1 by sigma E. So B is equals to what? 0.1 GT by BE Z square plus, or just see here. Let me show you this one. This is step. So after putting PB as sigma E into B, so I'm writing as sigma E into B is equals to 0.1 GT sigma E into Z square by BE plus S minus 0.2 GT sigma E into L by BE into Z plus P. This is there. Right. So now in this term, sigma E is there. S sigma E is not there. Here sigma E is there, and with P sigma E is not there. So means with these two, sigma E will be there. Okay. So now let's take sigma E common. So after taking sigma E common, what happened? Sigma E into B is equals to 0. Sigma E I am taking common from all. So this is 0.1 GT, okay, into Z square by BE, okay, plus same in bracket S by, because here sigma E is not there, so multiplying, dividing and taking sigma E constant, minus I'm just here, instead of taking same thing you are doing, so 0.2 GT sigma E by BE into sigma E into Z plus B by sigma P. So P by sigma E. Now just see, in denominator all the three terms having in this case 1 by sigma E. So just take common from 1 by sigma B from this side. And sigma E cancel. So B will be equals to 0.1 GT Z square by BE, okay, plus okay, 1 by sigma E constant, then this will be S minus 0.2 GT sigma E L by BE whole into Z plus P. That's here. So this is B equals to 0.1 GT by BE into Z square plus 1 by sigma E into S minus 0.2 GT sigma E L by BE into Z plus P. Substituting for PB from equation 8 in 3, right? So this is here, PB is there. Right. So now this PB value, we got the 2P, 2PA plus S, right? Where? In equation 3. So this is the final B. Now what we have to find? PA. So let's put this PB value in equation 3. So see here. Here. So this 2PB value. So now 2PS, 2PS, 2PZ. So from there we will get P after substituting this PB value. Okay. So now after substituting this value there, what we will get? PA is equals to 0.4 GT sigma E by BE into LZ minus Z square by 2 plus PS. Okay. So this will be the final what? PA value. Right. So before solving the numerical, let's see once again quickly. The question is what you have to do. You have to derive for the AS and B. Right. Okay. So for that, what we did, first take the top string and then the Shear, that middle one. So just draw the free body diagram. Take what? Next the Shear flow distribution, both the part. Now just consider the top part and middle part, or you can consider bottom part and middle part, because top and bottom are symmetrical here. So anyone you can just consider. So for the top we have got this one. This is the free body diagram, or you can say for the equilibrium is what? All this side should be equals to this side. All the forces acting in this side. So this side we have taken positive. So this, okay. So just see, this side also this force is acting. So this plus Q into del Z minus PB minus S into del Z equals to 0. So here. So here PB cancel, right? Take these two, this side, and then del Z, take del Z common from here, del Z get cancel. Finally, del PB by del Z equals to S minus QB. Okay. So now after getting del PB, similar way, del PA we have to find from the middle one. Okay, for the central stringer. So again, free body diagram. So this side PA plus del PZ into del Z, and this side PA is acting. This time Q is acting this side, and this also is acting this side. So that means minus 2Q will be there. So you just say the equation PA this minus this and minus 2Q into del Z equals to 0. Hence del PA by del Z equals to 2Q. Okay. Now we have del PA by del Z, del PB by del Z. Okay. So now for the equilibrium we have to apply all the forces should be equals to 0. So just see here, already we have taken this side all the positive. So this side what is there? PB and PB. So 2PB plus PA, and this side what is there? PP. So 2P minus PS minus S into Z and minus S into Z. So minus 2S into Z. So after this we got this one. So from here PA is equals to this one. Now later case we will find the PB value, we will substitute here, and then we will get the value of PA. Okay, so this is for what? That is for just compatibility, the displacement equation. So here that is given. So from here that must be equal, top should be equals to bottom. So 1 by epsilon A into dz equals to this one, right? This and plus B into gamma d gamma by dz into del z. That is there. This distance into del gamma by del z. So after expanding and simplifying, we will get d gamma by dz equals to 1 by b into epsilon a minus epsilon b. Okay. Now epsilon a, epsilon b just we have to replace. So what is epsilon a? Sigma a by e. Epsilon b is sigma b by e. That is sigma b is what? Given as sigma e. So sigma e. And what is given? Sigma a is 80% of that load is acting. So 80% of sigma e. So sigma a is 0.8 sigma e. Just put the value. So sigma, after putting these two here, we will get d gamma by dz as minus 0.2 sigma e by b. Now replace the gamma because we don't require gamma in terms of shear flow. So gamma is equals to what? Q by gt. So now after substituting q, this will be dq by gt. So gt will get multiplied here. So dq by dt is equals to minus 0.2 gt by b into sigma e. Now substituting for q in equation 6. Now substituting this q value. Right. So right, what is here? So from equation 1. So just see here. S minus q is this one. So from here what will be the q? Q is equals to S minus del PV by del Z. Right. That value here. Yes, this by del Z only. Okay. So we will get, after differentiating S is constant, so that S will be 0. Right. And this minus and minus becomes plus. So del 2 PV by del Z square equals to 0.2 GT by B into sigma E. Okay, now integrate this 2 times. I already showed you to integrate. So after integrating, what we will get? That PV equals to this one. Now once we have the value of C, we have to find C and D. Once we will find the C and D, substitute here. That is the final equation for PV. So now for finding C and D, what we have to do? We have to apply the boundary condition. So at Z, when Z equals to 0, PV is P. Just put that value. Then you will get D equals to P. Now second boundary condition, when Z is L, then Q is 0. So from 1, that is del P by del Z equals to S. After putting Q equals to 0. So del P by del Z equals to S and Z equals to L. Just substitute there. So after that you will get, because just now we had seen that del P B by del Z equals to S minus Q. So this Q is 0. So that this is equals to S. Simply just replace. So we will get C equals to this one. Now just put the value of C and D. So after putting the value of what? C and D here. So PV equals to this into C, Z plus D. So this is C value, this is D value. Now PV is what? Sigma E into B. Right. So sigma E into B, just replace. Right. And after that, just take C, sigma E constant, common. So after that, sigma E will get cancelled. B will be equals to 0.1 GT by BE into Z square plus 1 by sigma E into S minus 0.2 GT sigma E into L by B into Z plus P. So this is the final equation for B. Now we found B. Now next is what? PA we have to find. Right. That is just here. Right. Once we will have this one, then we can find this here, what is required. Expression for AS and B. So similarly like PV we found. Yeah. So once we will have PA, then we can find AS also. Right. So substituting the PB, that value is there. So after substituting PB from 8, right, this value, okay, where here we will get PA. So after substituting, we will get PA equals to 0.4 GT sigma E by BE into LZ minus Z square by 2 plus PS. Okay. Similarly, now PA equals to what? AS into A, 0.8 sigma E. So that equation 10. So after putting in that one, what we will get? AS equals to GT by 2 BE into LZ minus Z square by 2 plus 1.25 PS by sigma E. So now this is our final formula for AS. So now here derivation over. This is first B and then here AS. Now we find. Now what is that? The values. So means we have to find numerically the value of B and this one. So just everything is given for B, whatever is required, like sigma E value is given, G, T, G is also given in terms of E. so that you can put L, Z, all the values are given here, right? Just substitute that value. Z is not there, so Z is here, just here. So in this case also Z is not there. L value is given 1250 mm, right? So PS is also given, T given, G given, E given, B, everything is given. So just substitute the value, right? And then you will get B is equals to this one. So Z square plus, that is 3.8 into 10 to, just after substituting this value, 3.8 into 10 to the power minus 4, Z square plus 0.3227Z plus 1636.4. So now just see here you can see this is a quadratic equation. Simply you can put into the calculator in the quadratic form, or you can apply the formula, but applying formula will be somewhat difficult. So simply you can just put into the quadratic form, select the quadratic equation in calculator and just put the value of A, like ax square plus bx plus c. So here x is your z. So whatever the value of x you will get, that value will be here for z. So like that you can put. Now similarly you just put in as equation all the values, then you will get as equals to what? 2. Or this is minus, so this you can write here also. 2.375z minus 9.5 into 10 to the power minus 4z square plus 659.1. Again simplify by the quadratic equation, you will get the value of as. So just see, from equation 13, that is whatever the value is given, z is equals to, okay, 1250 mm, as is 2143.5 mm, right? Then PA will be equals to what? Whatever is there into AS. So PA, up to this only AS is required. If they ask in numerical that PA also is there, so PA is 0.8 sigma E into AS. Just put the value 0.8 sigma E is given. AS we found this one. So totally this one, PA. The total load PT carried by the panel inbuilt in. PT is 2 into that load is given 4,50,000 plus 1,45,000, the 2 PA plus PS plus 2 PB, that formula, right? 2 into 350 plus, or just here into 1250. So finally you will get 19,20,000 Newton, that total force. Now what is the fraction? Fraction is how much load is acting divided by the total load. So this is the load, the PA by PT. So fraction will be what? PA by PT. So that is PA is 471,570 divided by how much? 1920000. Once you will divide, you will get 0.25. So the fraction of load is how much? The fraction of load carried by the stringer is 0.25. So 0.25%, that is 25% of load will carried by the stringer. Okay. So here in that again you can just refer this question again is from the TGHG Maxen. So you can just refer that book. So again the here, what we have to derive according to this, okay, AS and B we have to find according to the derivation. Then next they ask to find the forces. So we found the forces also after finding. So first find the force, that AS and B. For finding AS and B, we derive the force formula also, right? So after deriving A and B, substitute the values and that quadratic equation will come. Solve for the quadratic equation, you will get value of AS and B and then substitute according to that one. Okay, so if you have any doubt, you can just comment on the video or you can contact me. I will clarify your doubts. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.